There are many different types of batteries. All right, so nickel cadmium, nickel metal hydride, these are rechargeable. These go in a lot of our portable electronics like cell phones or computers. There's lithium batteries, there's lead acid batteries like the ones we have in our cars, there's lithium ion batteries, those go definitely in our laptop computers, and then we have our standard alkaline batteries. For the most part, our standard alkaline batteries are not rechargeable. You can get rechargeable ones, but just the general ones are usually single use. Okay. Now, I'm not going to go into terrible detail on all of these different batteries because I'm going to task you this week in your discussion board with looking up different batteries and giving a little information about batteries as part of your discussion board this week. So this can be kind of a jumping board so that you can understand what types of batteries there are out there. So I've got a diagram and some reactions for each of these. So we have our alkaline batteries, right? And the processes that take place at the anode and the cathode, and then the overall reaction. All right, there's our button batteries that go in our watches. And I know on the videos, my little face covers up some of the reactions, but when you download the slides, you'll be able to see these much easier because my face won't be covering them up. Okay. There's our nickel cadmium batteries, so you can see kind of what those look like. There's the nickel metal hydride battery. And then our lead acid batteries. Again, these are what's going on inside of your cars. Okay, there's what a lithium ion battery looks like. And then I put a laptop computer on there so you know that this is what we're using in our laptops. Now, one thing that we have to consider with batteries is that sometimes they can catch on fire. A lot of our group 1A metals, very reactive to water. In fact, we have to store a lot of them in mineral oil because if exposed to air that has water vapor in it, they will react with the air. So we have to use electrolytes that allow us to not react with something like water. So like our lithium ion batteries, we have to use non-aqueous electrolytes. We have to make sure that they're sealed, they're not exposed to air. If something happens between the electrode compartments and it breaks that separator, that can short circuit things. We can get a lot of heat, and then we can get these exothermic reactions that cause fire. So like cell phones that have caught on fire, one of the things that's happened with those is either the battery has swelled and it's compressed things and it's broken the little separators, or the battery was a little bit too big for the compartment in the cell phone, and so it was squished in there and little microfractures happened that over time got worse, let things leak in, stuff reacted that shouldn't react, and boom, it caught on fire. Okay. And then we have what we call energy density that lets us look at the relationship between the number of ions stored in the electrode and the weight or volume of the battery. So various different batteries have better energy density for the size of the battery than other ones. So again, I know this was brief, but that's because I'm going to have you do a little bit of digging work on your own for your discussion board so that you understand where we use these different types of batteries and maybe how we get the components for them and things like that.